Hey guys, in this video I'm going to go over some of the problems that are going to be in the position and displacement worksheet that you've got today. Okay, so going to go ahead and get started here. It says solve the following problems. What is your final position if you start at -5 centimeters and make displacements of +10 centimeters and -3 centimeters? Okay, so we learned in the PowerPoint the other day that our final position formula, right, was x sub f is equal to x sub I plus d, where x sub f is final position and x sub I is our initial position. Okay, that's going to be where we start. We start there. That's x sub I plus any displacements. Okay, so this is one of them, and this is the other displacement. We can call that displacement 1 and displacement 2. Okay, from there, let's go ahead and substitute in our values. Well, we're finding final position, right? So I'm going to leave that one as x sub f. That's our variable. We're trying to find it. X sub I, substituting in the starting position, which is -5 centimeters, which is -5. Okay, I'll leave it as -5. I'll put the unit back at the end whenever we have our answer. Since we have everything is in the same unit, we can do that. Okay. All right. So plus any displacements we have. Well, our first displacement is 10. And our second displacement, right, we'll add it, is -3. Well, since it's negative, I'm going to put plus -3. Okay. And if you do that math, -5 plus 10, that's +5. +5 plus -3 is +2. Okay, so we have +2 centimeters, and that would be our final answer there. Okay. All right. The total distance moved. Okay, well, distance moved. Let's go ahead and use capital D for distance. Okay. Distance moved is equal to the sum of our displacements, absolute values, right? So in this case, we had 2 displacements, right? So the absolute value of D1, okay, these lines mean absolute value, okay, plus absolute value of displacement number 2. Okay, well, our first displacement was +10, so the absolute value of +10 plus the absolute value of -3 in that second one. Okay, -3. If we look at that, the absolute value of +10, well, how far away is that number from the number line? It is 10 positions away, okay? Plus, how far away is -3 from the 0 on the number line? Well, it's 3 positions away. Absolute value just means make that number positive. 10 plus 3 will give us a distance traveled of 13, and our unit, centimeters, okay? Okay, hopefully that's helpful. I would encourage you now to pause the video and try number 3 before I go over it with you. Okay, hopefully you had time to do that. What is your final position? Okay, so once more, it's asking us for x sub f, right? That's x sub f. If you start at +5 centimeters, x sub I, and make displacements of -10 this time and +3 this time. So that's once more our 2 displacements. Okay. Final position formula is xf equals xi plus d. We don't know what final position is, so we'll write that x sub f. F stands for final, I stands for initial. Okay, starting point. X sub I being this time +5. Okay, all of our signs are being flipped around. Okay, and then plus our 2 displacements. Well, our first displacement is -10. Remember, we're going to do plus parentheses -10. Okay, +3. And if we look at that math, positive 5 minus 10 is negative 5. Negative 5 plus 3 is going to be negative 2. Okay, and our unit is centimeters. Always include that unit there at the end. Okay, number 4 will be much the same as number 2. I will let you go ahead and finish this section. Okay, I did 3 of the problems, and you do the other 3. 1, 2, 3. All right. Number 7, I will help you get set up because it is different than the rest 1 through 6. What displacement can move you from a position of 8 centimeters to a position of negative 2? Okay, so what are we given? From a position, right? From a position of 8. Well, what's that telling us? That's telling us that we started there, right? So if we started there, then that's our initial position, xi, to a position of negative 2. Well, if we moved from a position to another position, they're both positions, so they're both going to be x. And this is where we ended up, right? That's where we ended up. So we'll put that as x sub f for final. Initial position, final position. Hopefully that makes sense to you. And then the other thing that it's asking is displacement. Okay, that's D. Well, what's our formula that involves those variables? Okay, you might be saying x sub f, the same formula up there, equals x sub I plus D. Whenever I say sub, I mean down, right? X sub f, that means f is down, it's lower, it's subscript. Okay, x sub f equals x sub I plus D. Well, let's fill in our variables now. X sub f, we are given this time, which is negative 2. So we'll substitute that value there, is equal to x sub I, this time 8, plus D. Well, what do I put for D? Well, it's asking for finding that, right? So if we need to find it, it's likely that we don't know it, which in this case we don't. That's what we're solving for, right? So we want to solve for letter D. Think of this as negative 2 equals 8 plus x. Okay, that's our variable. We're trying to solve for it. Now, we want to get x by itself, in this case D. In order to do that, what are we going to do? How do we get rid of that plus 8? You might be saying at home minus 8 from both sides, and you'd be correct. Okay, negative 2 minus 8, what's that? Well, that's going to be negative 10 is equal to, this goes away, right? Equals D. So our displacement is negative 10, and what's our unit? Centimeters, okay? All right, there's that. The following table shows position and displacement data. Okay, so number 8 is like that, and maybe a couple more on the back. Nope, just one more on the back. Okay, so I'll do number 8 with you, and you'll do number 9. Get you set up. Here we go, number 8. I'd encourage you to try it before I go over it. It's going to give you all the practice that you need sitting there at home, and you will get the check for understanding that I will go through it and make sure that you did it right. Okay, and if you have any questions, of course, send them to me. The following table shows position and displacement data. Fill in the missing data. Okay, so we don't know initial position. That's x sub I. I always encourage you to write in what values you're given. Displacement 1, that's D1, D2, and we don't know displacement 3. We do know final position, and we also know distance moved. Okay, this one is going to be quite tricky, I will say. We don't know D3, and distance moved, that's capital D, remember. All right, so what I would start with here, since we're missing a displacement and we do know distance, we know that our distance is going to be the sum of our other displacements. Okay, so in this case, 18 is going to be equal to, I'm going to take the positive values. Okay, remember over here I did the absolute values. I'm just going to do that to save some space on the worksheet here. Okay, so instead of writing these out and absolute valuing them, we're just going to do the positive values of them. Okay, 8 plus 6 plus our displacement 3, which we don't know, I'll just put it like that, D3. Okay, so 18 plus 8 plus 6 is plus D3 equals that. All right. So 18, we're going to combine like terms. 8 plus 6 is 14 plus D3. All right, what's D3? Well, to find it, we might subtract 14 from both sides. And you might already be saying it's 4, and you'd be correct. Okay, but for those of us who have more trouble with it, we'll go through it. 18 equals, well, that cancels out. 18 equals our D3. Wow, I messed up there. My bad, guys. 18 minus 14 is 4 equals D3. Let's just pretend that never happened. Okay. All right, so D3 equals 4. So right here on displacement 3, looks like there's a negative in front of that. So we'll make that negative 4. Okay, because it's negative question mark. All right, well, we found it, so it's negative 4. All right. Realize that that negative 4 would have been like absolute valued, and that's why we're going to keep it as negative 4. Okay, because it said negative, whatever that is. It just told us that it wanted it to be a negative value. That's why that negative was out front of the question mark. Promise it was there before I scratched it out. Okay, now that we know our displacements, we're going to find the missing data. Well, now the missing data is x sub I. Okay, now our formula is x sub f is equal to initial position plus our displacements. All right. X sub f being negative 3, right? Substituting in values, negative 3 is equal to x sub I. That's what we're finding. Okay, if we're finding it, I'm just going to rewrite the variable. Plus D1, which is 8, plus D2, which is negative 6. And last one is plus D3, which is negative 4. Okay. Yay, math. We get to do some adding in. Negative 3 is equal to initial position plus, well, what's 8 plus negative 6 plus negative 4? 8 plus negative 6 is positive 2. Positive 2 plus negative 4 is negative 2. Okay. All right. So we want to get x sub I by itself. It's being subtracted by 2, so we want to do the opposite of that. So how do we do the opposite of minus 2? Plus 2. Okay. And negative 3 plus 2, not negative 5. Remember, they're opposite signs, so we're going to subtract them and keep the bigger sign. Okay, so that's negative 1 equals x sub I. And negative 1, we'll put it right there. That's one of our answers, and that's the other answer. And we're good. All right, there's our answers. Cool. Number 9. I'll let you do this one, but it says move the initial position of positive 5. Oh, let me pause. Doing an announcement.
Sophomores, at this time, please transition to second.
All right, sophomores are going to second period. Move the initial position positive 5. What are the new initial and final positions? Okay, so while that's saying, it's saying move the initial position positive 5 meters. So on this one, our initial position was negative 1. So what's negative 1 plus 5? You might say positive 4. I'll help you out with these. Then we're just going to fill in the same values for our displacements. Okay, displacement 1, positive 8, negative 6, negative 4. Positive 8, negative 6, and what was the other one? Negative 4. Oh, man.
It's time, freshmen, please transition to second period. Freshmen, transfer to second period.
All right. Okay, so our final position is going to change off of that, but our distance should stay the same since we still have the same displacements, right? You should be able to figure that out, which is 18. All right, so number 10, right? I'll let you finish this. Remember, that's x sub f. Label all the variables that you've got, label them above. Feel free to do that. Very good. A hawk leaves its nest in Fort Worth and travels 3,000 meters east. Okay, after snacking on a tasty rodent, the hawk flies another 1,500 meters east. All right. Well, I'll go through letter A and letter B.
At this time, seniors, please transition to second period. Seniors, transition to second period.
Excellent. Okay, so letter A, it asks, what is the initial position and how did you choose it? So it's asking x sub I, right? Initial position is x sub I. So x sub I, what are you going to choose for the initial position? Okay, it left its nest. That's where it started, is its nest, right? Okay. If it left its nest and then it traveled east, let's assume that its nest is the origin. Right? So if it always starts at the origin. So our initial position is the origin.
Juniors, at this time, please transition to second period. Juniors, transfer to second period.
Excellent. So our origin is always 0, and our unit is meters. Okay, so hawk's nest. All right, the hawk's nest is the origin, and we chose it just because it said it started there. Excellent. Part B, what are the displacements made by the hawk? Well, we've got one displacement. That's 3,000 meters to the east. So D1. And there's two displacements. So we'll write D1 and D2. Our first displacement is 3,000 meters to the east. Okay, well, are we going to make east positive or negative? Well, east is to the right and west is to the left. Okay, so remember that they spell we, W-E. West and east. Okay, so east is on the positive side. It's to the right. West is negative. So let's make east positive. Okay. And our first displacement is 3,000 meters east. So you might say positive 3,000 meters. Okay, what's our second displacement? Well, it flies another 1,500 meters east. Okay, good. What is the hawk's final position? I'm not going to go through this, but I'll get you set up. It's asking for this using that formula, okay? And the last one is total distance. Remember that total distance is going to be, you can just make the two movements positive and add them together, but this is the formula if you care to use that. Absolute value of D1 plus absolute value of D2, since there's only two. Okay? All right, guys. Otherwise, good luck. And I will talk to y'all later.